So in this video we're talking about covalent bonding, and in particular molecules or compounds that are held together by covalent bonds. So before we get too deep here, let's talk about a couple things up front. The first thing that's important to really put in your head about covalent bonding is that this is not about ions, right? That's what ionic bonding is for. Ionic bonding is formed or happens when ions are formed and atoms gain and lose electrons to make ions, to make substances. This is not a game of gaining and losing electrons, so there's no ions involved. Well, if we're not gaining and losing electrons, how is this happening then? Covalent bonding happens because of a sharing of electrons. Right, so atoms will share electrons with one another, and that will kind of make the bond. Another big concept to keep in mind is the idea of the octet rule. Right, and all this means is that atoms want 8 electrons, or 8 valence electrons. So those are 3 things to kind of just generally keep in mind about covalent bonding. Another thing that's good for us to talk about up front is the notation. So we need to be able to designate bonds and electrons. The electrons will designate by, so say we have element A, or an atom of element A, which isn't a real element, but just for an example, we'll show electrons by putting dots around the A. So if A has 3 electrons, say, you'll see 3 dots sitting around A. And actually, technically, what people generally do here is, even though these dots are not representative of where these electrons actually are, the electrons do spread out as much as possible. So you shouldn't really even see 2 electron dots next to each other like I have here. So I'm actually going to get rid of this guy and put it kind of on the other side. Get my pen back. Just to kind of signify that the electrons are spreading out. The other thing that we'll see is we'll see bonds. So we will designate single bonds with a single straight line between 2 elements. I'll show this in a more clear example in a second. A double bond with two lines between the 2 elements. And you can actually rarely have a triple bond, which has 3 lines between the 2 elements. So a better example of this is, say that element A has a single bond to element B. You'll just put a straight line in between it. And so on and so forth, right? If element A has a double bond to element C, that's what it'll look like. If it had a triple bond to element D, you'd see 3 little lines in there. All right, so this is just kind of our background stuff. Put a big line, so we can kind of keep that separate. All right, so let's look at an example of this. And again, things to keep in mind. This is not about ions. We're sharing electrons, and we're going to share electrons to fulfill that octet rule. So let's look at, this is a great example for this. Let's look at carbon dioxide, right? So carbon dioxide has 1 carbon and 2 oxygen molecules. So this thing is covalently held together, covalently bonded together, right? Carbon dioxide is the stuff that you breathe out, or some of the stuff that you breathe out because of cell respiration. So, nice little hint here about covalent bonding is what we're really looking to do is draw what's called a Lewis structure, showing how these atoms are being held together. And they don't all need to be bonded to each other atom, but they all need to be held together in some kind of a form. So one thing that's really nice about this is that typically the first element that you see is in the middle. It's not always true, but it's kind of a good general rule, and the truth is the ones that it's not true for, you get to kind of know them, and it works out pretty well. So carbon is going to be in the middle of my Lewis structure, and carbon has 4 valence electrons, so I'm going to draw 4 electrons, and remember I'm going to spread them out as much as possible here, like kind of across the 4 sides, at the top, the bottom, the right, and the left. And then there's going to be 2 oxygens, and I know that carbon's in the middle, so my 2 oxygens are actually going to be on 2 of the sides. I could have picked the top and the bottom, I just had more space on the 2 sides, so I went with that. And oxygen has 6 valence electrons, so let's put 6 dots. 1, 2, 3, 4, and there's our 6, right? And do the same thing over here. That's 1, 2, 3, 4, 5. Those are my 6 electrons for each of the oxygen. I just put them in this kind of configuration just to spread them out as much as possible. I really wasn't thinking about it too much. So now these things are going to make bonds like we did up here between our kind of fake elements to satisfy all of the octet rules here, right? So let's just kind of go through and try to highlight some stuff, right? Let's say, remember, a bond, right, when we're talking about covalent bonding, a bond is really just a sharing of electrons. So let's say carbon shares one of its electrons, with oxygen, and oxygen does the same, right? That's why I kind of circled in yellow. So let's say those two are going to make a bond and share. Well, that's good, but it doesn't get oxygen up to the right amount, right? Oxygen would have 1, 2, 3, 4, 5, 6 of its own, and then 7 from this carbon. So that's not really fulfilling the octet. It's closer. And obviously the carbon's not there, right? 1, 2, 3, 4, and 5 for carbon. But we're getting there, right? So when we make a bond, both elements, or both atoms rather, get to count those electrons. So these 2 electrons that I've circled are shared. So oxygen gets to count both of them, and so does carbon. So if you noticed, right, when I made that bond, when I circled those electrons saying that the bond will make and these electrons will get shared, oxygen got plus 1 electron. So that's an important idea. Every time you make a bond, that element kind of gets to count 1 more electron. There's very rare situations in which that's not the case, but almost all the time, that's a good rule of thumb. So think about it. If I make another bond, if these 2 electrons get shared as well, this isn't really a bond yet, I'm just kind of mapping out what's going to happen. Now my oxygen will have 1, 2, 3, 4, 5, 6 of its own, and 7 and 8 from its carbon. So now my oxygen would be at its octet. My carbon's still not there, right? Right now carbon's only at 6. But what could we do? Well, carbon has this other oxygen on the other side that it can bond with. So we'll get something similar on the left that we had on the right. Right? So oxygen will share 2 of its electrons with carbon. Carbon will share 2 of its electrons with oxygen. That brings our oxygen up to 8, right? 1, 2, 3, 4, 5, 6 of its own, 7 and 8 from the carbon. So that's got an octet. And now let's go back and count the carbon. 1, 2, 3, 4 of its own, 5 and 6 from one oxygen, and 7 and 8 from the other. So now this guy is up at an octet too. Right, so this is how the electrons will share. We'll have 2 bonds between the carbon and one oxygen, 2 bonds between the carbon and the other oxygen. This is not a Lewis structure though. If we want to make it a Lewis structure, we have to show those shared electrons as bonds like we showed up in the right there. So what we'll do, we'll rewrite this guy and we'll say carbon's in the middle. It's got a double bond because there's 2 sharings of electrons here. We've got 2 bonds, right? This one and the one below it, to an oxygen, and then a double bond to the other oxygen. The only thing that I'm still missing in my Lewis structure here, right, is that, so that shows how carbon has its 8. It's got 2, 4, 6, 8 in those bonds, but it kind of implies that my oxygens don't have enough electrons because I stopped drawing in the lone pair, the non-bonded electrons that you see. So I need to go put those in. So 1, 2, 3, 4. And the same thing on the other oxygen. 1, 2, 3, and 4. So this is a quick example of covalent bonding and kind of playing the game of drawing. Remember, this is called drawing Lewis structures.